Hey, what's up, guys? So today I want to share with you a very interesting algorithm called the karatsuba algorithm. Okay, so this will be a very short video, but I introduce this algorithm because I think this is creative and interesting. Okay, so idea is that how to multiply two bit numbers. Okay. So idea is that let's say you choose base to be 2, or you can choose base to be 10. Basically, any positive integer greater than 1 is okay. Okay, so consider let's go back to like your high school. So if you want to times this, then you can find this, right? And you do the addition. Okay, so total you will take O and square multiplications. Where multiplication is to get the results. Okay. Why 2 n bits? Let's say you get n1 and n2, then it's very easy that you can just choose max n1 and n2 to be n, so such that you can transform this question into 2 n bits. Okay, so this karatsuba come up with very simple idea that you can solve this in the easier, more efficient. So idea is, let's say you choose base to be b. Okay, and assume that let's say you can write x to be x1 bm plus x zeros, and then y to be y1 bm plus x zeros plus y zeros. Okay, so for example, let's say I can write 1, 2, 3, 4 as a 12 times 10 squared plus 34, and I find 5, 6, 7, 8 to be 5, 6 times 10 squared plus 7, 8. Okay, so in this case, that m is 2 and b is 10. Okay, and in this case, n is 4, right? Because there are n bits, so I can, without loss of generosity, I can set n is a power of 2. Okay. Okay, I want to do the multiplication x and y, so this is trivial, right? Just do your simple mathematics. You get x1 y1 b2m, and x1 y0 plus y1 x0 plus x0 y0. Okay, so since each of xi and yi lesser than b, so you don't need to worry there's a b to m, right? So you don't need to worry about that. These two will give you additional power here. Will give you b to a 2m power, because this is impossible. Okay, so you can write this as a z2 b2m plus z1 bm plus z0, and obviously that z0 is just x0 y0, and the z1 is x1 y0 y1 x0s, and the z2 is x1 y1. Okay, so naively, if you do the number of multiplications, you can see this multiplication, this multiplication, this multiplication, this multiplication. So you take 4 steps. Okay, to do the multiplication. So if I use the divide and conquer, let's say I define T of n to be the number of steps that you need to multiply to n bits numbers. Then this will give you T of n, right? You separate into T divided by 2 because you separate this as this. And then you do, once you do this, right? Once you do this, then you get 4 steps, right? You get 4, right? Plus the maybe big, let's say plus a big O of n, right? Because you need to do addition. So this is addition. Okay, then you can use a master theorem that I will not prove here, but I will post the proof below that I previous prove it, so you can check it. So your T of n is basically O n squared. Okay, but this a very amazing karatsuba, this guy come up with this fancy idea is the following. So z0 is x0 y0, z1 is x0 y1 x1 y0, and z2 is x1 x2 y2. Sorry, x1 y1. Okay, so this is give you one obviously idea that you can. I mean, this is very simple, right? If you have some feeling about mathematics, that obviously that I can write z1 as this. minus z0 minus z2. So I only need I only need the 2 steps. I only do additional 1 steps, and these are already computed. So I only need 3 steps to do the calculation. So t of n is 3t n divided by 2 plus O of n. Okay, then if you use the O of n's, right, and then now you can use the master theorem. Oh, sorry, this is you can use the master theorem. Okay. Okay, so once you use the master theorem here, right? So this is you can prove that this is n log 2 or 3. Okay. Go of this. Okay, so not difficult to prove it. So you can use a master theorem. Yeah. So. Okay. I think that's it. Okay, so that's it. See you guys next videos.